Yes, hi guys. So next time continue with beta and gamma functions because there are a number of questions which are taken from student queries, online queries mostly, and these questions are again the same. Depth of beta and gamma function. I'm just further discussing. The same topic beta and gamma functions or gamma and beta functions. Okay. Beta and gamma functions, as I introduced in the previous lecture, that beta and gamma functions are Eulerian integral units. Okay. First Eulerian integral is the beta function. Second Eulerian integral is the gamma function. Okay. Their definitions, then interrelationship between them, what relationship between beta and gamma function, that also are defined. I'll just mention here the formulae which are known as Eulerian integrals or Euler's integrals. Okay. About Euler, I have already discussed about the history of his. Okay, so about him I have already talked about. So no need of talking about Euler. But now at the moment I'm talking about the questions which are based upon beta and gamma function. These questions are further in the knowledge depth of knowledge. Okay, this I'm going to the deep of the studies. Okay, so this study about beta and gamma function is important for the students who are appearing for the exams for graduation, mostly engineering exam, and university exam. Okay, so even Integ also, or the research students who are studying the research purposes, they can also go through beta and gamma function. How they are, as it is known as the gamma function or second Eulerian integral, and this, the first also, they are the fundamental for definite integrals. Okay, they are basics for definite integrals. Okay, because of that, they are also important. Now let me discuss about. So I've talked about what is beta function, what is gamma function. That we discussed about, but let me go down the formula of it. Okay, so beta function, first is beta function that we talk about. What is beta function? We denote beta function as beta mn, where mn are positive numbers. They may be positive integers as well. Okay, but maybe other numbers also. So beta mn is equal to 0 to 1. This is x raised power n minus 1 into 1 minus x whole power n minus 1 dx. This is known as beta function. Okay, and about these formulas we will just apply them. And what is a gamma function? Gamma function is noted as, okay, let me take gamma n. Gamma n is noted as 0 to infinity. If x raised power n minus 1 e raised power minus x into dx. This is gamma function denoted as gamma n. Gamma n is 0 to infinity. If it is gamma n, we will take here n minus 1. This is only difference. E raised power minus x dx. This is gamma function, beta function. This is known as second Eulerian integral. This is second Eulerian integral or Euler's integral. A Eulerian integral. Euler's or Eulerian integral. This is the second one. This is the first one. First, or simply write first. This is the first Eulerian integral or Euler's integral. That we write Euler's integral or Eulerian integral. Okay, integral. So first and second Eulerian integral, they are fundamental for the definite integral. That I have already described about. These formulae are very important. We apply them and how they are applied and the relationship between them. What is the relationship dot? That also we have discussed about what is the beta and gamma function, how they are related to each other. Beta mn is given by gamma n divided by gamma n plus n. This is the relationship between these two functions. When beta function and gamma function. Gamma function, beta function, they are related to in this way. Okay, this is the relationship. These three things will be required to solve these questions. Because that are now then, and already I have discussed about. Let me take now questions. What are the questions here? Okay, this is further discussion about the same topic, beta and gamma function, because that was not sufficient. I have already Okay, taking the previous lecture series in which 18 questions I solved. Now the further 18 questions, because these questions are important for the student because they have asked me further discuss about this in depth of knowledge. Okay, this is the deep in the topic that I am going to discuss now. This is question number. Now let me take first one. Question number first, how to solve it. Let me solve the question number one and others, and for one by one that topic will be, I'll just I can claim that this is the depth of the topic, beta and gamma function, how they are solved. So these questions are solved, they are for beta and gamma function. Let me discuss about that. Question number one now. We have to prove, okay, 2 raised power n gamma n plus half is equal to 1, 3 into 5 and so on. This is twice n minus 1 under root pi. This we have to prove here. Okay. Now we know that. Let me take this topic here. Since gamma n plus 1.2, let me prove here. This is proof. I'm solving this solution. I'm giving gamma n plus 1.2. Let me describe this in this way. This is twice n plus 1 upon 2 after taking LCM here. Okay, so this is twice n plus 1. Okay, now this can be written as, okay, this is twice n minus 1 upon 2 plus 1 if I write down. No change. Why? Because if I solve it, this is plus 2, this is minus 1, this is minus 1 plus 2 will be plus 1. So 2n plus 1 upon 2 is still the same thing. This can be written like this. Okay. Now, what was this one? We know that gamma n plus 1, since gamma n plus 1 equals n gamma n, this we know about. Okay. Gamma n plus 1 equals to gamma n into gamma n. One lesser than this becomes this n into gamma n. Similarly, if I write it down, this plus 1 will be eliminated. This will be equal to, therefore, gamma twice n plus, sorry, minus 1, minus 1 upon 2 plus 1. This is gamma. This plus 1 is in between, left right here. Okay, this is equal to how much? This is twice n minus 1 upon 2 gamma twice n minus 1. Simple. So this is, suppose n plus 1 into n into gamma n, n into gamma n. Here in place of n we have twice n minus 1 upon 2 n plus 1. If it is n plus 1 equal to n into gamma n, that means for n gamma n. Similarly, this twice n minus 1 upon 2 is in place of n. So this is this value. Further, this can be written as twice n minus 1 upon 2. This, if I subtract further minus 1, that will be minus 2 further will be subtracted. But minus 1, that means 2 LCM will be twice n minus 3 upon 2 gamma twice n minus 3 upon 2. Okay. So in this way, we can extend this. This is twice n minus 1 upon 2. This is twice n minus 3 upon 2 into twice n minus 5 upon 2 gamma twice n minus 5 upon 2. Okay. In this way, if we extend this function, we will obtain twice n minus 1 upon 2. This is twice n minus 3 upon 2, twice n minus 5 upon 2, and so on. Last step will be 5 by 2, 3 by 2, and odd numbers are coming in the numerator, and even number 2 is coming in the denominator. And this is 1.2 into gamma 1.2. This is the series we can write down. This is the series. Now, if I assemble them, and this 2 is coming n times, but we have started from twice n minus 1. So we can write it as twice n minus 1 in bracket, twice n minus 3 in second bracket, twice n minus 5, and this 1 is 5, 3, 1 into gamma 1.2 is under root pi, square root pi. Okay. This is 3, 1 divided by 2 raised to power n. Y plus 2 into 2 into 2 into n times. That means 2 raised to power n. This is what? This is the value of n plus 1. This is nothing but gamma n plus 1.2. This we are solving because this value is nothing but this n plus half. Gamma n plus half is equal to this. So if I cross multiply, this implies that 2 raised to power n gamma n plus half is equal to, I can write down this first 1, then 3, 5, and so on. Into 5 can also be written number and or maybe in the beginning. And last is twice n minus 1. In the end we can write twice n minus 3 into twice n minus 1 under root pi. But this is the value we have obtained. So 1 into 3 into 5, twice n minus 1, the last step, and under root pi into multiplication. So this is the same value, we have just cross multiplied them. This is how we have obtained this answer. And proof. So this is the proof of the first function, first question I mean. First question is put. This is how we have to apply. Okay, this beta function as well as gamma function we have applied. This is gamma function here, beta function. Okay, so gamma function is here applied. This is question number first. Let me talk about the second question. Now, question number second. Let me. Okay, so question number second is of what kind? Let me discuss. It says show that showing this. This is to show. Question number second to show here that 0 to pi by 3. Okay, this is 10 n theta d theta is equal to 1.2 pi into secant n pi by 2. This we have to prove. Okay. So let me take the left hand side here. So this is left hand side 0 to pi by 2. This is 10 raised to power n theta d theta. Okay, we can write it down as 0 to pi by 2. This is sine n theta upon cos n theta d theta. We can take cos n theta in the numerator. This will be 0 to pi by 2. Sorry, this is sine n theta into cos minus n theta. Sorry, this is minus n theta d theta. What is the final value of this? This can be calculated as the value of this sin n theta cos n theta. We know that this is how it is to be written down. The value of this will be, let me write down, gamma 1.2 n plus 1. This is when 0 to pi by 2 sin n theta cos n theta. If it is first will be n plus 1, but here in place of n we have minus n, in place of n we have n, which is the first one. Second one will be again 1.2 in the bracket, it is minus n plus 1. Okay, w bracket closed. This is gamma divided by, okay, this is twice gamma. Question number, okay, we have to just find out. This is 2 times gamma n plus 2. This is n, sorry, 1.2 again. Here 1.2 n minus n, okay, n plus 2 here. Okay, this is n plus 1, n plus 1 plus n plus 1. Okay, n plus 1, n plus 1 divided by 2. This is the value of here n plus 1 minus n plus 1. This is how we write n is n plus 2. Okay, so this n plus 1 plus minus n plus 1 will be n minus 1 here, n minus n plus 1 plus 1 plus 2. This is how we have done. Okay, so this value is equal to the numerator we are having. Okay, n plus 1 upon 2, and the second one is okay, minus n, or this is minus n plus 1, or 1 minus n, 1 minus n upon 2 divided by, in the denominator we are having n and cancelled out. This is only gamma 1, 2 upon 2 gamma 1. So gamma 1 is 1 here. Now this, if I write, let me note down this. The first one is we are writing similar, same, n plus 1 upon 2. The second one, if I write 1 minus n plus 1 upon 2, is there any change here? Let me just show you this. This is 1 because this gamma 1 is equal to 1. This is 1 here. 2 into 1 is 2. But what about this value? This is, we know that since gamma and gamma 1 minus n is equal to pi upon sine n phi type condition. This value gamma n or gamma 1 minus n is equal to, this is n here, this is n pi, pi upon sine n phi. This we have proved in the previous lecture series. Okay, so this value is similar here. In place of n we are having n plus 1 upon 2, 1 minus n plus 1 upon 2. If I solve this, we will get the same thing, minus n plus 1. This is minus n minus 1.2, this is plus 1 plus 1.2, this is plus 1.2, minus n.2 plus 1.2, the same thing. If I solve this, we will get the same thing here, minus n plus 1.2. And but we can write in this way, n 1 minus n type, but here in place of n we have n plus 1.2. So what is the value of this? This is nothing but 1.2, this 1.2 as it is, and gamma n plus 1, that is pi upon, it will be pi upon sine n plus 1 upon 2 into pi, that is 1 upon 2 n plus 1 into pi. The value in the angle we are having n plus 1 upon 2 into pi. In place of n we are having n plus 1 upon 2 into pi. Like this. Okay, so this is the value here. Now let me further solve it. For the further solution of this, let me write it here. Okay, so finally, left hand side, this left hand side, we have obtained this much. Let me write it further. This is pi upon, if I write it cosec, let me write in the numerator. This is what? Pi into cosec, because 1 upon sine is cosec. This is no n pi of 1, first let me write pi upon 2. This is pi upon 2 plus n pi upon 2. No change, because this is, I multiply pi into bracket, it will be n pi plus pi. That means pi upon 2 divided by n pi upon 2. This is the value. So what is the final value of this? If this is, we know that cosec 90 plus theta is secant theta. It is nothing but secant n pi by 2. Since cosec pi by 2 plus theta is equal to secant theta. Okay, so this is pi by 2. pi by 2 plus theta proportion. In case of theta we have n pi equal to 2. This will be secant n pi by 2. Finally, this is the value here 1.25 secant n pi by 2. Economically, so hence it is good. Or this is the answer final. Final answer is this much. We have obtained the same answer as in the right hand side. This is the right hand side here. Left hand side we were solving. This is the right hand side we have obtained 1.25 into secant n pi by 2. Okay. This is how we have obtained this. So this is again usage of beta function as well as gamma function. Here it was gamma function. Application of gamma function we have applied. Now let me take next question. Question number 3. Okay, what is? Let me take question number 3. Now question number 3 it says to show that again going to show what to show that yeah, this is 0 to pi by 2. Again same type of question. Under root this is square root tan theta, this is square root from tan theta into d theta. This is equal to, we have to prove here, this is 1.2 gamma 3/4 gamma 1.4 is equal to 2 into 0 to infinity. This is x square dx upon 1 plus x4. This we have to put. These are two right hand sides. So this one first we have to put, then this is equal to this one we have to put. This is equal to. So let me take left hand side. Left hand side. Here we have 0 to pi by 2. This is square root tan theta d theta. We can write it as 0 to pi by 2 sine raised power half theta into or divided by, let me take cos half theta d theta. This is half power. The square root is 1.2. Power is 1.2 here. So this is 1.2. Now I can further this as 0 to pi by 2. And this is sine over half theta. This is cos minus half theta d theta. So we know this, what is the value of this? Just by formula since, let me write here 0 to pi by 2 sine n theta into cos n theta d theta is equal to gamma 1.2 n plus 1. This is first gamma, second one, which is 1.2 n plus 1. Okay, this is the second one divided by twice gamma n plus 1 plus 2. This is the value of this. Since 0 to pi by 2 sine n theta cos n theta d theta is equal to 1.2. This we have proved in the previous lecture series. Okay, so this is 1.2 n plus 1. 1.2 n plus 1. Okay, so this value let me take, we just from the value whatever was given to us 0 to pi by 0 to infinity, we put sine theta in place of x, we put sine square theta, and then we got this one. So in the previous lecture we had just proved this. Here we are applying the formula which we have proved in the previous lecture. Okay, so we have to find out this question. This value will be equal according to this formula. Equal to how much? This will be gamma in bracket 1.2 curly bracket here. In the bracket it will be 1.2 plus 1. First one. Second will be 1.2 minus 1.2 plus 1. Okay. Divided by twice gamma 1.2 in the bracket, it is half minus half plus 2. This curly bracket closed. This is this bracket. Since this is the form, with the help of the formula we have applied here. So what is this then? Finally we have obtained in the first gamma we have this curly bracket. We have this 1.2 plus 1 is 3 by 2, 3 by 2 into 1.2 is 3 by 4. Second is, this is minus half and plus 1, that means plus half in the bracket. Multiplied to half, that means 1.4 divided by, when this minus half plus half cancel out. 2.2 is gamma 1. And gamma 1 we know that gamma 1 is 1. Since gamma 1 is equal to 1, if you say this value 1.2, 1.2, this is 1.2, gamma 3 by 4 and gamma 1.4. This is the first level which we have obtained. This is equal to first level. This is 1.2, gamma 3 by 4, gamma 1 by 4. This is the first level. First level, or you may say the first right hand side, or first right hand side. This is obtained first right hand side. Now I have to put this to that value. Now let me take this further. So from this result let me take further. So we have obtained here 1.2 gamma 3.4 gamma 1.4. Now try to understand. We know that beta m is equal to gamma m divided by gamma m plus n. This we have in the beginning. I wrote down this formula that there are relations between beta and gamma functions in this way. Beta mn equal to gamma m divided by gamma m plus n. If I cross multiply, this will be okay. If I let first let me take gamma m plus n into beta mn into gamma m plus cross multiplication will be equal to gamma m into gamma m. This one we have obtained here. Okay. Here gamma m plus n into beta mn equal to gamma m plus gamma m plus gamma m into gamma m plus this gamma m equal to this cross multiplication. So it means this in place of these two values. We can write in this way. What is this value? So let me write this down. So in place of gamma 3 by 4 and gamma 1.2, we can write in this way. What it will be? This is beta n is 3 by 4 and n is 1.4 into gamma m plus n. M plus n is 3 by 4 plus 1.4. So this value we have obtained here. It is 1, but 3 by 4 plus 1.4 after taking 4 LCM. 3 plus 1 is 4, 4.4 is 1. This is nothing but 1.2 beta 3 by 4 1 by 4. 3 by 4 1 by 4, and this is gamma 1. Since gamma 1 is 1, so this value is equal to 1. This is gamma 1 to 1. This we have obtained as beta 3 by 4 1 by 4. But this we can express as 0 to infinity. Okay, 0 to infinity. But let me take y here. Y is power 3 by 4 minus 1. 3 by 4 minus 1 here divided by, this is first m minus 1 upon, this is 1 plus y. If I write 1 plus y here, the whole power will be m plus n. That means m plus 1.4. What does it mean? Because we know that since beta n is equal to 0 to infinity. This is either x raised power, this is x raised power n minus 1. If it is first n, then it will be n minus 1 divided by 1 plus x whole power. Here, divide this sum is n plus n. Okay, this since this is going to be switched by the same logic we have obtained, where we have substituted place of beta and n this value, which is by 3 by 4 minus 1 upon 1 plus y whole power 3 by 4 plus 1 into d by. This is here it is dx d by. So it means this, let me careful this further. So we have obtained here this result. Let me take here y, we could take x, no problem, any value can be taken. 1.2 minus 0 to infinity we have. Y is power, this is minus 1.4. Why? Because 3 by 4, if I take 4 as 0, 3 minus 4 upon 4, that is minus 1.4 divided by 1 plus y only. Why? Because 3 by 4 plus 1.4 is 1. Power is 1 here, this is only 3. Now let me further solve it. Now if I put here y equal to something, let me take x. If I substitute, let or putting y equal to x4, because we have to take it into x4, y equal to x4 we are watching here, that 1 plus y, so y let me take x4 here, differentiating it with respect to x, differentiating it with respect to x, we get this is dy upon dx equal to 4x cubed. This is 4x cubed here. Okay, or dy equal to 4x cubed into dx. Okay, this is in place of dy we will substitute here. What are the limits here? Let me change the limits. The limits will be the same, I think, because when y is infinity, x is of infinity, same limits as